Okay. Reasonably okay. Is voice okay? Fully audible? Display is perfectly okay, I think. Voice audible? Okay. No, that side don't worry. Right side, I have noted down some answers because to save the time. Partially covered. You don't have to worry about it. Everything will get in the class. But just to checking purpose, when I was free in the afternoon for this frame and the next frame, question 1 and 2, I noted down something. Because sometimes if a mistake comes, to overcome the mistake. So don't worry about some numbers you can see here. This is not for you. That is not for you. Okay. Now, first of all, remember information for those who are in the group. That is indeterminate structures. By slope deflection method, moment distribution method, and Carney's method, tell me what you will get. Whether it's a continuous beam or rigid jointed plane frame, irrespective of what, non-sway or sway type, tell these methods will give what? Tell me. These displacement methods, SD method, MD method and Carney's method, what it will give? Tell the answer. It is very important. These three methods I told, SD method, MD method and Carney's method. These three methods finally what it will give you. Fast. Do not delay the day because otherwise you cannot complete today. These methods will give what? No answer. These methods will give what? If no reply comes, I will stop the class then. It will give you member end moments. See, member end moments. For every member, what are the end moments? That's all. Now, that's all it will give you. Once you get, see, I written here. This is your question number 1. This frame we solved by already slope deflection method. Tell yes or no. By slope deflection method, we already solved. Tell me yes or no. This frame was already solved earlier by slope deflection method, and these are the final member end moment we got. All are in kilonewton meter. Remember, final answer, no plus minus. You write correct direction. When you put correct direction, you should not use minus plus sign. It is nonsense. This I told so many places earlier. See, suppose fixed end moment is anti-clockwise. If you mark anti-clockwise, then writing negative, it is a nonsense and what? Complete mathematical blunder. Common sense required. But majority are doing. They will put anti-clockwise here and write minus WL square by 12, etc. I don't know what is their idea. When someone told me earlier, that is later minus. I will tell later minus means when you substitute use minus sign. There you write clockwise positive. See, this is anti-clockwise, so minus sign there. Do not write anti-clockwise here and minus sign. Clear? This is called high school level mathematics. Clear or not? First of all, you should know that one. Okay. This I am telling repeatedly, class after class. This mistake you should not do. Okay. Then, further, these are the moments you got. Now, question number 1, these are the moments we already got by slope deflection method. Remember, this is not in YouTube. This question we solved by SD method, and next further classes we will solve this frame by MD method and Carney's method. But I am so sure that all three methods will give same answer. Therefore, this is star book. Clear now? This is star book. Star means what? To draw SFD BMD. What to do? Okay, see now. Enter the end moment. You draw a line diagram. Show all the member end moments. Members, I am using somewhat green color to understand. Okay, then I am rounding off the values to second decimal, sufficient. Now, see, already in the earlier class, SD over. Maybe further classes, not in YouTube, I will solve the same question by MD method, same question by Kani's method in Zoom only. Clear? In subsequent classes, I will solve by what? I will solve by MD method and Kani's method. That is not for general public. But general public, what I am giving is how to draw SFDBMD if you know member and moments. One more thing. This is a frame. So, those who are watching and want to learn, they should have some elementary knowledge. How to find support reactions and bending moment, how to calculate, what is sagging, hogging, what is BMD on tension side, little knowledge required. If they don't have that much, it is a waste for them to go through my class. Some they may comment. We went to a class there or attended a class, nothing clear. Nothing clear because you are not knowing anything. Or they should refer my old SFDBMD class in the channel. There if you understand correctly, you can understand. So, anyway, why I am doing YouTube? Because even for those who are in the group, after some time, I am deleting the classes in Zoom. But BMD SFD permanently you require. So I decided, let it be in the YouTube so that this will be permanently there. Purpose of doing SFD BMD in YouTube is that you can any day refer. Clear? Any day you can refer. For that purpose I am doing. Okay, start. Now, what all I tell, you should write. See, this is a question number 1. Every support taken fixed. To draw SFD BMD, what you do is, see, to draw SFD BMD, we need what? We need, what you require is, not vertical reaction. Remember, for a horizontal member, you require vertical reaction. For a vertical member, you require horizontal reaction. Or we need reactions normal to member. Normal to members. Normal to members. That is, for horizontal member, you require vertical reaction. These are required. For vertical member, you require horizontal reaction. See, for horizontal beam, this will create what? Bending. Here, axial force is not considered. Here also, axial force not considered for SFD BMD. See here, axial force, here axial force is horizontal. So horizontal member, you don't require horizontal reaction. Vertical member, you do not require vertical reaction. But actually remember, I will tell you later that vertical reaction or vertical these two, that will give compression for the column. So for practical knowledge, vertical reaction for columns are important. Yes or no? Vertical axial force for columns are important. Axial force for beams, we are not interested. Okay, start. Because someone will tell, this is fixed support. There is a horizontal reaction is there. He has not accounted. I will tell you, learn somewhere else, not from me. Okay, now start. First consider AB. AB is a horizontal member. For every member, okay, this time I won't use color. Horizontal member. It has got UDL. You got lot of work today. UDL of 30 kilonewton per meter. Length of member is how much? 6 meter. Okay, now this is A, this is B. So if the member is this way, there will be react. Now consider ends. At the ends, what is there? Okay, I use a red color. Unknowns, I use red color. Here. What is there here? Here, see, when you apply load this way, there will be a vertical reaction here and vertical reaction here. I will call VA and VB. Oh, it's not writing. Some problem always. Right time not writing. 1 minute. Other color? No, I won't get it. Because I want red color now. Today I won't get it. Because I want it now. If I want, I won't get it. When I do not want, red will start coming one after other one. Wherever I touch, I get red color. See, searching all the pens here. No, it had decided not to come. Illa. Yes, not there. This is also not there. Where is it? Let me see here. No, this is horrible. See, this makes me so angry. When you require, you won't get it. When you do not require, you get it. Illa. Just a minute. Where I placed the red color, I don't know. Somewhere I placed it. Just a minute. See. There is one here. Is it red? Yes, red. Okay, finally got. Okay, there is a vertical reaction VA here, vertical reaction here VB. Okay, now VA VB. Then there will be horizontal reaction. We don't require. Now remember, the horizontal reaction for the beam is statically indeterminate. Nobody can find based this property. See, now when you go to SFD-BMD, that 3I, 1.6I, I, 2.5 I are not required. Why? You don't require I. Still are given. Why? Because suppose somebody knows the subject. He want to understand correctly SFD-BMD. He knows SDMD Kani's method. Then he may think, let me solve by my own knowledge. So for helping him, I have given the EI values. So that if he wants, he can solve and he has to get the same moment what I got. So if somebody may be there who want to solve by MDSD Kani's method, maybe they are knowing. So that they should not tell, I cannot solve because EI values are not given. So what to do? He may think EI constant. If he takes EI constant, this result will not come. Therefore, to make those who are having knowledge, to help them, I have given EI. Otherwise, EI is not required. Now see, now this member axial force, I am sure that when you apply the force this way, this member is likely to be in tension. I know it. You don't bother why. I know it, tension. Same way, this member also will be in tension. This member will be in compression. But we don't require it. Clear? We don't require it. We don't require. But I am showing why. Because there is a horizontal reaction existing there. We are not interested for SFD-BMD. Not required. Clear? I am showing because I know this member will be in tension. This also will be in tension because of this loading. This will be in compression. Okay. Now, next further, there will be member end moment. Member end moment. How? Here, see there, MAB, anti-clockwise of 103.19 kilonewton meter. Here, MBA, clockwise of 63.62 kilonewton meter. Now you have to find reaction. Tell me, can you find the reaction? Only one member I will show you. See, sigma m about A equal to 0. Take clockwise positive. Take moment about this point. Minus VB into 6. VB into 6. VB is a red color, unknown. Minus VB is unknown. Okay. Minus VB into 6 plus 63.62 plus 30 into 6 into 6 by 2. Next, minus 103.19 equal to 0. Therefore, you get the value of VB. Tell the value of VB to me fast. Tell me the value of VB fast. I know the answer there, but I want it from you. Tell the second decimal, VB. VB value. Tell the VB value. 83.41. Thank you. It is plus 83.41. One nimsha. It is plus 83.41 kilonewton. Then sigma V equal to 0, upward positive. What do you get? Plus VA plus VB minus 30 into 6 equal to 0. You know the value of VB. Therefore, tell the value of VA. Tell the value of VA fast. Tell the value of VA. 96.59. Okay, thank you. Plus 96.59 kilonewton. So, later, when I write free body of AB, I will mark vertical reaction of 83.41 and here vertical reaction of 96.59. Clear? Clear or not? Both I got positive, both are upward. Clear? Later, horizontal, I only mark, I am not interested. Clear? Horizontal, I will mark it, but I am not interested. Okay, no problem. No problem. Okay. Clear or not? Now tell me clear or not? Later, because I am rubbing the board, answer is somewhere there. I have noted down the answer. Okay. Okay, now see, next, consider BC. Consider BC. I am rubbing one by one. BC. When you consider BC, see, this way. This is B, this is C. Span is 4 meter. There is a point load of 200 kilonewton. 200 kilonewton. Distance is 2 meter from here, out of scale, 2 meter. There is a vertical, B I will put here now. This is B, this is C. Okay. There is a vertical reaction here, VB, vertical reaction here, VC. So, your VB comes second time. You can do one thing. This VB you can call V to BA, V to BA. Clear? Into V to BA, or you can write one thing. You can write VB1. VB1. This I will call VB1. Correct? VB1. This I will call VB2. And this is VC. Once again it comes, I will call VC1. Then, this member I am expecting axial compression. Why means you don't bother. I know it. It is surely axial compression. Then, there is a moment here. See, if it is a continuous beam, if it is 63.62 clockwise, this will be 63.62 anti-clockwise. No, this is a frame. There are 3 members are there. 3 members together will be in equilibrium. So this moment will be different moment. That moment will be 103.96 kilonewton meter. This moment clockwise of 123.73 kilonewton meter. Start. Tell me the value. Sigma m about B equal to 0. Take clockwise positive. Tell the answer. Fast. Minus VC1 into 4 plus 123.73 plus 200 into 2 minus 103.96 equal to 0. You will get the value of VB2. Fast answer. VB2. You get the value of VC1. You get the value of VC1. Answer. Those who are serious should write it. VC1. Answer. Those who are serious, they will write. Those who are not serious, I cannot do anything. 109.94, correct. 104.94, correct. I can check there. It is plus 104.94 kilonewton. Calculate. Then, sigma V0, take upward positive, VB2 plus VC1 minus 200 equal to 0. You get the value of VB2. VB2 will come plus 95.06 kilonewton. Correct answer? Tell me. Answer correct? Okay. Now, next member. Consider CD. When you consider CD member, see here. This is CD member. There is a vertical reaction VC here, second time, and vertical reaction VD. And this is C, this is D. There is a point load of 150 kilonewton at 3 meter from there. Total span is 5 meter. There is an anti-clockwise moment of 65.15 kilonewton meter, a clockwise moment of 93.42 kilonewton meter. Here, take axial force. I am so sure this member will be in axial compression. You don't bother. Sigma m about C equal to 0, take clockwise positive. Minus Vd into 5 plus 150 into 2 plus 93.42 minus 65.15 equal to 0. You get the value of Vd. Answer. You get the value of Vd. I got the answer there. I got 65.65. Correct? Is it correct? 65.65. Correct? Okay. 65.65 kilonewton. 65 kilonewton. Then sigma V equal to 0. Take upward positive plus Vc2 plus Vd minus 150 equal to 0. You get the value of Vc2 plus 84.35 kilonewton. Remember, all the reactions we got positive. It means assumed directions are correct. So later in the free body, I will get the same reaction. Now, one important principle I will tell you now. This is question number 1. After this question is completely over, I am going to question number 2. When I go to question number 2, if not today, tomorrow. Question number 2, this support D is hinged. Support E also hinged. Yes or no? The frame for question number 2 is, see, it is hinge here and hinge here. Tell me yes or no, fast. Yes. Therefore, for that question, this moment is 0 and this moment is 0. That time, I won't waste time. Can you find reaction? When you take CD member, this moment is not there. And not only that one, then someone will tell, same answer will not come. But see, some will tell, sir, same answer will come. No. Since it is a hinged support, even all the values are changing. The member and moments are going to be changing. Yes or no? So all this value will change. I will write the changed values here. Then these calculation I will not tell once again. See there, because of hinge support here, this moment is not there. But this is not 65, some other value there. So that question also, can you find reactions? Tell fast. Second question, this free body I am not writing. Can you write systematically and get it? Okay, done. That is for those who are serious. Shall I remove this one now? No. Shall I remove this one now? Beams. Shall I remove these beams? The beams part, shall I remove? Oh, no, shall I remove that beams? Okay, now one more thing. I will remove the beams. When I go to question 2, I will tell you only solve. I already noted down the answer there. Get the reaction. Someone will tell, he is not showing calculation. I will tell what you are doing last time. When I go to second question, this moment value will change. Some places 0 will come. 0 means don't write. Over. So I will remove these beams now. Okay. Now, one small important information for you. I will tell you later. One small important information I will tell you later, not now. Those who are serious. Those who are not serious, why should I tell anything? Now, consider vertical members. See, horizontal members are over. See, later, when I go to frames with sway, I will not explain this much. I will give direct answer because why? Once I explain such a mega problem, easier. Next, consider vertical members. Vertical members. Now, remember, first consider BE or EB. You can call whatever you want, BE. See, this is BE. This is B, this is E. The height of that member somewhere right is 5 meters. There is a point load here of 100 kilonewton at 3 meters from here. Then there is surely going to be what? There is going to be end moment. End moment. Top moment is here 40.34 clockwise. 40.34 kilonewton meter clockwise. Bottom side moment is anti-clockwise of 63.83. When you go to second question, this is 0. Okay, then Now there is going to be, see, when you apply load this way, there will be reaction like this. Expected like this. We will take like this. Suppose it is wrong, negative will come. So this is HB, this is HE. Correct? That is HB, this is HE. And very important, there will be a vertical reaction here. And if it is down, this will be up. This is VE, this is VB. Anybody can tell me what is this VB equal to? Now you can tell the answer. Anybody can tell me what is that VB equal to? That is a direct load transfer to column. Anybody can tell? For your information, I can find the VB if you want, column load. Tell me that VB equal to. Tell me that VB equal to. Tell me that VB equal to. Anybody can tell what is that VB? I already told you in earlier classes. See, when I take AB, I got a reaction VB1. When I take BC, I got a reaction VB2. That is a reaction on the beam from the column. Now, load is transferred from the beam to the column. Anybody can tell? It is your VB1 plus VB2. If that is upward, this will be what? For the beam, if it is upward, for the column, it will be what? For the column, it will be direction. Action, reaction. For the beam, it will be upward. For the column, it will be downward. Okay. Those who are in the BSK group or those who are in the my regular group understand. General public, I am not interested because my purpose is to teach SFD BMD. This will not have SFBM effect. So others need not bother. If you understand, well and good. When I teach something, I want everybody to understand. It is not that only those who are my students should understand. If others understand and be happy, I also feel happy. At least my efforts are used for them. So, but those who are in the group, clear? Those who are in the group, if it is clear for you, my headache is over. Those who are in the group, if it is clear, yes, my responsibility is over. Because for them, I have to teach more. Clear? Okay, done. Now, see here. Take moment about any point. Take moment about B. Clockwise positive. See here. Plus HE. Be careful. HE is unknown. Plus HE into 5. Clockwise. Then minus 63.83. No into. It's a moment. For second question, this is not there. Then minus 100 into 2. 100 into 2. Then plus 40.34 equal to 0. Anybody can tell me what is the HE value? Fast. I know the answer. I noted down every answer. See, I'll tell you. For this question and for next question, to find all the reactions, it took me only 3 minutes. Why? 1.5 minutes for this question, 1.5 minutes for that one. In the 3 minutes, I not only got reaction, I even got the bending moment values, where shear force crosses the baseline, if it is unknown point, the bending moment, everything I got. Why? I am applying tricks actually there. Those tricks are not for you. You tell the answer. 35.30. No. 35. 55 antalli. It is 55, I think. It is 55 point, I think, not 35. I can see there 55.3. See, you typed wrong value, I think. No, 44.7. Correct. Base reaction is, you will get plus 44.7. Positive means what? Direction is correct. Suppose you by mistake, you assume wrong direction, negative will come. Later in the free body, you reverse it. Okay, then sigma m0 over, for beams what you do? Sigma m0 and sigma v0. Tell me for vertical member, sigma m0 and not sigma v0. What? Tell me. Sigma what now? Not sigma v0. See, for vertical member, we want this reaction. Sigma what? Now not sigma V0, now sigma H0, sigma H equal to 0. Take right side positive. Okay. Minus HB minus HE, then plus 100 equal to 0. You already know HE value. Substitute that value and tell me what is the HB value. Answer. It will come plus. I am sure. It will surely come plus because this will become that side. Answer. Is it plus 55.30? Is it plus? Yes, it is plus 55.30 over. Therefore, when I put the free body for this column later, what I will do? At the base, I will mark a left side reaction of 44.7. At the top, I will mark a left side reaction of 55.3. And also, for those who are in the group, I will apply a vertical load of sum of those two, VB1 and VB2. Clear? For those who are in the group, others all SFDBMD. Those who are in the group, I will apply a vertical load here of VB1 plus VB2. Clear? Tell me, clear or not? I will apply sum of those two VB, reverse it, I will apply here. If clear, tell me. Over. If clear, my work is over. Okay, now, lastly, consider which member? Lastly, consider CF member. CF member. Okay. When you take CF member here, study. C is here, F is here. There is a UDL here. Okay, I will put CF later. UDL of, how much it is? 60 kilonewton per meter. The total length of member is 4 meter. And there is a moment here and moment here. The top moment is anti-clockwise of 58.58 kilonewton meter and bottom is clockwise of 90.71 kilonewton meter. Then there is going to be a vertical reaction down here. This is C, this is D. A vertical down. This is I will call VC. This VC will be equal to that beams VC1 plus VC2. VC1 plus VC2 is upward, reverse it, downward, it will give compression. Clear? Clear or not? Those who are in the group, clear? Sum of those two reactions will be transferred here. Clear or not? First. Those who are in the group should tell clear. Okay, done. And there is same vertical reaction here, VD, not required for us. And then horizontal reaction. See now, this member, load is acting this way. I assumed reaction like this. Here load is acting this way. So we'll assume reaction opposite to loading. HC and HD. Okay, start. Take moment about C. Sigma M about L. Okay, take moment about D. Any point will do. Sigma M about D equal to 0. Take clockwise positive. Moment about D. Plus HC into 4 minus 58.58, then minus 60 into 4 is the total load into 4 by 2, then plus 90.71 equal to 0. Tell me what HC value first. It will come plus. I know the answer. My answer is 111.97. Is it correct? I calculated, I got 111.97. Is it correct? 111.97. Is that reaction correct? Okay, over. Now, lastly, sigma H equal to 0. Take right side positive. Plus HC plus HD, then minus 60 into 4 is the total UDL equal to 0. You know the value of HC. Tell me part HD value. HD value. Part HD value. Over. If you give that value, over. Time being over. HD. Is it plus 128.03? Yes, it is plus 128.03. Therefore, remember, next when I go to SFD-BMD for the frame, for this member, I will enter this HB reaction, enter HE reaction. I won't call, okay. And then for this member, I will enter HC reaction. See here, I got both positive. Here also positive. But here, I assumed this way, correct. Here, I assumed that way. How I assumed that way, I will enter the reaction. By chance, if any reactions comes negative, what do you have to do? When you enter for SFD-BMD free body later, whichever you got negative reaction, that one you reverse it and apply. This is also clear. When you consider that reaction for next time, no minus sign. In case you got negative, you reverse it and apply. Clear? If clear, okay, I am almost ready now. If clear, I am almost ready. Tell me, clear or not? Fast. Anywhere if you get negative, later sometime negative will come. You are not answering. Okay, start. Now, I will remove everything now. Now, this is for question 1. I will tell now only. Once I finish question 1, I will go for question 2. At that time, this is hinged support, this is hinged support. You already know the moments, yes or no? You already know the moments. You already are at the end of the class. I will do one thing. I will enter the moments here. Clear? At the end of the class, once I finish this question, I will start question number 2. I will put the frame and enter the result for that member. And when you come to next class, can you find all the reactions and get ready fast? Tell me, when you come to next class, can you get all these reactions and get ready? So that I don't have to waste time. Once again, sum of moments are 0 there. Tell me, I will give the moment. Actually, Suresh has sent the answer. It is perfectly correct. I saw it. Even I checked the answer. No, when you come to next class, can you get all these reactions so that I can directly start from SFD-BMD? Yes or no? If you agree, okay. If you are agreeing, it will save the time. Right today, but I will do one thing. Moments I will give. Even any general public, yes, you do one thing. If you cannot solve by SDMD Kani's method, result I will give you. Result I will give you. At least use equilibrium and find. You are not agreeing. If it will agreed means I can understand. It is a word yes. Agreed? So that I will tell you last time explain. Okay, done. Now I will make see, now is the most important. How to draw SFD-BMD for different members in case of frames. Especially bending moment, you should be careful. Okay, start. I will write correctly and start now. What is the systematic procedure of drawing SFD-BMD? See, I removed all the values because answers are there. I noted down. As you gave the answer, I simultaneously checked it there. Answer was tallying, therefore, I don't have to check once again. Okay, now see. Now, see, what to do? Make a note. If you want to draw SFD-BMD, then what you require is, you first write free body diagrams. Now, see, now next step is, you make a note here. Note. What is the note? The note is that, the note is that all reactions are over. Now, final entry. Okay, now, write free body of each and every member. Then, okay, using the result. Okay, start. Free body for all members. Space problem is there. AB member. AB is here. Limited space. I will use limited space here. AB here. I will leave some space here. I will write BC here. Space problem. I will leave a space here. I will write CD here. Then some more space I will leave here and write a little down. This is your BE. This is your CF. Okay, see. Now, I will enter all the loading. 30 kilonewton per meter. Span is 6 meter. Here, 200 kilonewton load. 200 kilonewton load at little more. Okay. At 2 meter from here, span is 4 meter. Span is 4 meter. And here, 150 km load. I can go a little bigger. Here, 150 km load at 3 meter from here. I will put later. Span is 5 meter. I will first finish the beams. This is your, I will use color for the points. 1 nimisha. I will use particular color for the points to understand now. Or members, I will make somewhat green color. All members, I will make green color. Okay. Point A, B, B. Actually, this gap is not there. I am separating it here. B, C, C, D over. Okay, then I will enter all the reactions which you got just now. There is a vertical reaction here. Vertical reaction here. Just now you calculated. A vertical reaction here. A vertical reaction. Vertical reaction here. Vertical reaction here. Now, I will not write VAVB. I know the answer. This reaction is 96.59 kilonewton. 59 kilonewton. Other reaction is 83.41 kilonewton. This reaction is 95.06 kilonewton. This reaction is 104.94 kilonewton. This reaction is 84. I won't write VAVB. 35 kilonewton. That reaction is 65.65 kilonewton. And there will be axial force. I am so sure that this member will be in compression. This member, no, that member will be in tension. That member will be in tension. You never bother. Never bother. This will be in compression. I am so sure. Some will ask, sir, why you are so sure? Don't worry about it. Compression. Tension. Why means I got little structural knowledge. Okay. I don't require. Then, moments we already got by what? MDLT Carney's method. Moments also, I will enter red color. Anti-clockwise moment. Remember, enter in the closing bracket format. Moments. Neatly enter so that no difficulty for you. Moments. Where is it? Moments here. 103.19 kilonewton meter. 63.62 kilonewton meter. That member is 103.96 kilonewton meter. Board fully visible? Tell me. Board fully visible? Or shall I put the camera down? Tell, is the board fully visible? Or camera should be down? Shall I reduce the camera down? Is the values of moment fully visible for you? Later you will tell, sir, not visible. Is the moment entered all fully visible? You are not answering. All the moments entered fully visible for you? Little down better. Okay. So that little down. Okay, done. Little down. Now, what about now? Now, okay. Is that red color not fully visible? Tell me. Is that red color not fully visible? Shall I enter black color only? Is that red color not visible or not visible? Can you see the number clearly? Any problem? or any problem for display. Is the number entered or clear or not clear? Because of light problem. Is the display is clear or not clear? Because of light problem. You tell me. Black better. Okay. I will do one thing. I will slightly remove the light. That light reflection is giving trouble. Okay. Now let me see. Let me see now. Because if you don't see the number properly, black better. Black only better. Okay. I will enter black only. Black only better. Okay. I will enter black only. Okay, leave it. Why? Because important is understanding. Okay, leave it. I will enter black only. Why confusion? Okay, leave it. Because most important is understanding. Okay, I will enter here. We got a vertical reaction here of 95.69 kilonewton. Vertical reaction here of, this is B point, 84.31 kilonewton. Here vertical reaction of 95.06 kilonewton. Vertical reaction of 104.94 kilonewton. Vertical reaction of 84.35 kilonewton. Here vertical reaction of 65.65 kilonewton. And this member, I am so sure, when you apply load here, this will be in tension. When you apply load this way, this will be in tension. This will be in tension. This also will be in tension. I am so sure, you don't bother. Whereas this will be in compression. You don't require it. Okay. Then moments. I'll enter the moments now. Very important. Enter the moments. Moments are closing bracket anti-clockwise. Here clockwise. For this member anti-clockwise. This member clockwise. This member anti-clockwise. This member clockwise. Okay. Those moments are 103.19 kilonewton meter, 63.62 kilonewton meter, 103.96 kilonewton meter. This is 200 kilonewton, partially rubbed out because of touching by hand. 2 meter. Okay. This is clockwise of 123.73 kilonewton meter, anti-clockwise of 65.15 kilonewton meter, clockwise of 93.42 kilonewton meter. Okay. This is a free body of all horizontal member. Now do one thing. See, actually there is no gap here. The gap is imagination. These are B, this is B. Now, somewhere here, I will write free body for the column. Here, somewhere in between. One here. Then I have to, little space problem is there. Okay, I will manage. Okay, here. Okay, available space. Little space is less here. Okay, available space. Okay, this is here. There is a point load of 100 kilonewton at 3 meter from here, and this length is 5 meter. Then for this load, there is a reaction here of H. This is the point E. This is the point B. HE we got left side of 44.7 kilonewton. 70 kilonewton. Top you got left reaction of 55.30 kilonewton. 30 kilonewton. And we got moment, this member, there's a UDL here of how much? 60 kilonewton per meter. And the height of that member is 4 meter. I'll write here, space problem. And there's a reaction here and reaction here. This is your C, this is your F. This reaction we got 128.03 kilonewton. There's a reason. Okay. 128.03 kilonewton. This reaction we got 119. Color, once you touch it, it goes 119.97 kilonewton. And moment at the top here, there is a clockwise moment. Clockwise moment. Here anti-clockwise moment. Here there is an anti-clockwise moment. There is a clockwise moment. This clockwise moment is 40.34 kilonewton meter. See, as neat as possible. Anti-clockwise of 63.83 kilonewton meter. Here moment is anti-clockwise of 58.58 kilonewton meter. Clockwise of 90.71 kilonewton meter. I made as correct as possible. And if you want, there is a vertical reaction here and a vertical reaction here. A vertical reaction here. Vertical reaction here. Remember, this vertical reaction, those who are interested, this reaction is sum of these two. This reaction is sum of these two. You write yourself only. Okay. See, 84.31 plus 95.06 is this reaction. Same way here. 104.94 plus 84.35 is this reaction. There is no place to write. No problem. There is no place to write. So I am not writing it. Okay, no problem. Clear? This vertical reaction is 84.31 plus 95.06. It is upward for the beam, downward for the column. It is upward for the beam, but downward for the column. Same way here. 104 point, how much? It is 104.94 because of the ink spreading. Okay. Change my theory. 104.94. Ayo. Some other color. Same thing. If I don't want a color, color will come. 104. So this reaction is 104.94 plus 84.35. Add those two, reverse it, enter here. You told agreed, enter here, enter here, enter here, enter here. It is not required for SFD BMD. Okay, now we will go for shearing force and bending moment diagram. See, I will first write shearing force diagram here. All values are in kilonewton. All values are in kilonewton. 1 minute now. See, when you draw this, and then once the shearing force diagram is over, I think I can finish here. Then I will go for bending moment diagram. Remember, bending moment diagram, not sagging, hogging, on tension side. On tension side. All values are in kilonewton meter. I told you that is how the software will give you. When you draw BMD on tension side, plus minus should not be there. Lastly, for those people who are academic oriented, I will tell you how to draw bending moment diagram using superimposing principle. Okay, done. I will start SFD BMD. I will prepare the frame here now. See how, see now this time, remember, no gap. When you draw BMD, see again, same problem, all color mix up. Okay, see here. Shear force diagram, space is not there. I write shorter. A, B, sorry, space problem. A, B, C, D, little bigger. So that available space, okay, I will manage here. Hey, what is this? Oh, so. Then there is a vertical member here, 5 meter length, vertical member of 4 meter. See, sorry, space is not there. So little small I will draw, correct? Little small because space problem. You draw big. Agreed? You draw big only. Agreed? Because of space problem, I write small. BMD, I want more clearly. I write here BMD. BMD, I will draw big here. 5 meter and this is 6 meter, 5 meter, 4 meter and 5 meter. Okay. BMD, I will draw big. Here, because of space problem, little small. Agreed? But 1 minute now, non-stop talking. I would like to have at least 5 minutes break. No problem. Just 5 minutes break. I will take 5 minutes break because talking too much. Okay, don't leave the class. You correctly understand now. During 5 minutes break, don't waste time. Correctly observe what all entered there. What all entered there, correctly observe. Don't waste time. I will come in 5 minutes. If required, I will extend the class beyond 9 for some time. No problem. Okay, I am ready. Just 2 minutes. I start now. No point in wasting time because I will complete it today. Remember, those who are in the group, BMD, SFD for the frames will be completely explained today. So that later you should not tell in the class when I take the frames with sway, I will draw SFD, BMD, but I will not explain this much. You should work out at that time. That is not here in the Zoom class. When I continue the course, there, this much I will not explain. Okay, no problem. I will not explain this much in the group later because you should go to, that's why I am doing the YouTube today. So any day you can refer permanently. Okay, start. Now see, shearing force diagram, all in kilonewton. Sign for the beam will be left up, right down, positive you can take. For column, it is your choice. First of all, remember, for shearing force diagram, important, how is the diagram? But when you design, do you require plus minus sign for shear force? Tell me. In RCC or steel, do you require plus minus sign for shear force? When you design RCC or steel, no. Therefore, sign, I will put some sign here. And bending moment very important. Why? Because in the RCC, when the bending moment comes, where tension comes, that side steel bar you have to provide. That is AST. Other side, if required, compression steel. So start. Shear force diagram. I will see one more thing. I will tell you now. For horizontal beam, shearing force is like this. This is already over 100 times. For vertical member, shear force is like this. Clear? For horizontal beam, vertical forces will give shear. For vertical member, horizontal forces will give shear. Full clear? Okay, now start. I won't explain much because everybody can draw. See now, start from here. I won't ask you anything. Start here. Go up by 95.69. Nodi. Go up by 95.69. From here to here, come down by 30 into 6. 95.69 minus 30 into 6. It will give you down 84.31. When you reach here, it is 84.31. I will write later. So SFD will come this way. This is upper side, lower side. You can call plus here and minus here. This point required. I will call the point as A, B, C, D, etc. New point. See, A, B, C, D, E, F are standard point. A new point I will call E. E. Let it be X from here. X from here. Can you get this X value? I will give the direct answer. 30. X will come 3.190 meter. X will come 3.190 meter. Correct? One nimisha. 95.69 divided by 30. 3.190 meter. E already there. A, B, C, D, E, F. I will call G. Okay. 1 minute. This X value, you know how to calculate or not? See, those who are general public, they should know that much. You know how to calculate that one? You know? Okay, thank you. Then, start. This member, go up by 95.06. Go up by 95.06. No load up to here. Come parallel to baseline. Come down by 200. Oh, heavy fall. That will be 10. See, this value is how much? This value is, how much is the value? That value is 84.31. I will write here. 84.31. See, it will be 104.94. Then, no load up to here. Go back. Go up by 104.94. Shear force diagram is there. This is the point where SFD crosses the baseline. It is exactly this point. A, B, C, D, E, F, G, O, H. I will call the point as H. Okay. Now, go to last member. Go up by 84.35. 84.35. no load up to here. Up to where? Up to here. Then come down by 150. When you come down by 150, it will be 65.65. Then no load, go back. Shearing post diagram. See the points I will write now A, B, C, D. To understand, I will name the points because why? Points are important. This is A, this is B, this is C, this is D, this is E, this is F. Shearing point, this point I will call A, E, G, H, I. I will call the point as I. New point, no location. Shearing post diagram for horizontal member, fully clear. Shear post diagram for horizontal member, fully clear. SFD for horizontal member, fully clear. Okay. Now, vertical member. Vertical member, shear force is this way. You do one thing, start from here. See, start from here. Go left by 44.7. I will take bottom this way, 44.7. Then, no load up to here. Up to where? Up to 3 meter. Somewhere here, no load. Go right by 100. Right by 100. That value will be 53.3. Then again go up and no load. Lastly, come back by 53.3. Oh, out of scale. I should reduce this one, 44.7. Okay. This is 44.7. This is the shearing post diagram for this point. That is this point. I will call J. I will call this point as J later. Lastly, this member. You can start from the top if you want. So anywhere you can start. Okay, start from bottom only. Instead of going left, go right side by how much? 128.03. Then from here to here, come left by 60 into 4. So when you reach here, there is a problem. Why problem? It will overlap. It will be 119.97 only over here. This way. See, this value I will write here. That is 119.97. Then go back. I will have separately here. This is shearing post diagram for the column. A new point came here. Hij, I will call K. Tell me. Shearing post diagram. See. Go up, come down, go up. Go up, come down, go up. Go up, come down, go up. Come left, go right, come left. Go right, come left, go right. Shear post diagram, fully clear? Now, again here, there is a point here, you have to locate. That point, I will take X from here. You know how to calculate the point X, correct? From similar triangles or anyway, you can calculate X. By 60. That X will come 2.134 meter. It will come 2.134 meter. Okay. I will calculate here some space problem. 2.134 meter calculated. So all this fully clear for you. SFD. You write neatly, not here. Here space problem. Sorry, if I write big, I cannot write in the board. I managed to squeeze in there. So, but you should write neatly, little big sketch. Agreed? Okay. Now, go for bending moment diagram. See, for bending moment diagram, be careful. We want BMD on tension side. But still, you require, while calculating, you require sign convention. But what you do is, you calculate the bending moment based on sagging positive. I am telling class after class. You take sagging positive. Then, if it comes plus, that means BM is sagging, tension at the bottom, plot bottom side. Suppose when you take sagging positive, if the value comes negative, that means bending moment is hogging. Tension will be at the top. Plot the value on the upper side. Clear? So horizontal beams, what you do is, if you get plus, what you do is, plus means tension will be what? Sagging, tension unloaded side. Negative means tension will be on the loaded side. Clear? See, minus means hogging. Tension is on the loaded side. Positive means sagging. Tension is on the unloaded side. Okay, start. Now, first start calculation. Nodi. AB member, sagging positive. Nodi. BM at A equal to, look this side, minus 103.19 kilonewton meter. BM at B, look this side, no clockwise, anti-clockwise. I told you, people who tell BM based on clockwise, anti-clockwise, they do not know structural engineering. See, hogging 63.62 minus 63.62 kilonewton meter. Then also bending moment at a new point, that is called G. At G equal to somewhere here, see, somewhere here at what distance? 3.19 meter here. So minus 103.19 plus 95.69 into 3.190 minus 30 into 3.190 into 3.190 divided by 2. Tell the answer to me. Tell the answer with sign. Tell the answer with sign. Remaining member, you have to do it. Remaining, I will dictate, you should do it. Tell the answer. No. What reverse? Sir, CF member, yes sir. No, I will take right side for the member, loaded side. I will take this is positive. Okay, no, there is no rule that way. Do you think I am not knowing that much? For this member, I will take shear force. This is positive. For this member, I am taking this is positive. Do you think I don't know that much concept? Do you think I don't? You are telling my SFD wrong. How you can tell it? That much common sense I am not having. I may do mistake in the calculation or writing or spelling rarely, but not in technical concept. Now, tell the answer. BM at G. Answer fast. What is the BM at G? BM at G. Answer fast. You are wasting time. BM at G. Nodi. If you don't tell BM at G, time wasted. 95.69 square divided by 60 minus 103.19. Is it plus 49.42? Is it plus 49.42? 357. How it is possible? Minus 103.19 plus 95.69 into 3.190 minus 30 into 3.190 into 3.190 by 2. How it can be that much? Plus 49.42. Correct. It is plus 49.42. Okay. Now I will do one thing. See correctly. We got negative. Negative means hogging. Tension at the top. We got negative. That means hogging. Tension at the top. We got positive. That means sagging. Tension at the bottom. Now I will not tell for other member. Clear? Remaining two member, I will not explain. Clear or not? Negative means hogging. No minus now. Tension at the top. Sagging means positive you got. Positive means sagging. Tension at the bottom. Okay. Therefore, clear or not? So this I will not explain for remaining two members. Because in the course, this I told thousands of times. Okay, start. Now plot the values. How much here? Here it is, see, hogging 63 point, sorry, it is more. It is 103.19. No minus now. Tension side. Here it is 63.62. 63.62 is this ordinate. I will put later. See, this is 63.62. I will write later because overlapping is there. And at the At how much distance? At 3.190 meter, it is bottom tension of, it answer you told just now, 49.42. Okay. See, this is 49.42 here. Then joined by UDL parabola over. Two quarter flexure will come. Those who want, they can locate it. Okay. This is the BMD on tension side for AB member. A, see, this is B, this is C, this is D. Clear? BMD for AB, fully clear? I will enter later. Okay, now start. You should do it. BMD for BC, here bending moment, minus 103.96, somewhere here. Little more than this one. 103.96. Now I can write here. Idu 63.62. Okay. That is for this value. Bending moment here, minus 123.73. Still bigger. 123.73. Bending moment here equal to, look this side, minus 103.96 plus 95.06 into 2. You should calculate. I am dictating here. Minus 103.96 plus 95.06 into 2. That will give you plus 86.16. That means sagging 86.16 here. Only here. Up to here. 86.16. Joined by a straight line. Why? Point load. This is the BMD on tension side for this member. Okay, start. Now this member, hogging minus 65.15 here, 65.15 here, minus 93.42, 93.42. Then bending moment here, look this side, minus 93.42 plus 65.65 into 3. Y plus minus, class after class I shouted in the SFD BMD course, more than 120 videos are there. Oh, sorry, not videos. 120 classes are there. I don't call video. It is not for joke. Plus 65.65 into 3. It will come plus 103.53. Plus 103.53. Okay. I will plot here 103.53 at 3 meter here. See, somewhere here. Saku. 103.53. Remember this value, not this value. This is the BMD on tension side for this member. This point is, that point is I point. This point is H point. And this point is your G point. Okay. Beam completely clear. BMD for the beam completely clear. For the beam, BMD completely clear. I will go to vertical member now. Vertical member is very important. Okay. Now go to vertical member. Little careful. I will tell you vertical member, what is the problem? Vertical member. This all you enter the calculation. Now consider AB. Consider AB. See, AB, do one thing. This is the member AB. Load is here. I will assume this is sagging. Clear? You have to assume, see, for horizontal member, sagging, hogging, clear. Vertical member, you assume one of them. Your choice. I will take, see, this beam. This beam, if it bends this way, it is sagging. Clear? If I assume this beam, because loads are here, I will assume this is sagging. Clear or not? Clear? I will assume as per the load, sagging means go inside. Okay, start. Now, bending moment at B. Here. See, this is sagging. That means, or I will do one thing now. See, AB, member, load is here. This I will take sagging positive. Therefore, how? See, to sag, you need this moment and this moment. This is called sagging. Agreed? Nodi. if I stand here, this is called sagging. Yes or no? Nodi, you stand here. See, this is called sagging. Tell yes or no. Fast. Yes. Now, bending moment here is this way. So, minus 40.34. That means it is hogging. Hogging means actually not that way. It is hogging this way. Tension which side? Tell me. Tension which side? Here bending moment is hogging. Here hogging. Tension left side or right side? Tension on left side or right side? Tension will come on left side. So left side tension. Same way, bending moment at E is once again, notice here, it is here. Once again hogging, minus 63.83. That is again hogging, tension on the left side. Then bending moment at this point, what is the point called? That point you are calling as what? Name. J. This is called J. BM at J equal to, look this side, minus 63.83 plus 44.7 into 3. Tell the answer. Tell the answer with sign. Tell the answer with sign. It is, see here, if I stand inside the beam, this is hogging, this is sagging. This is sagging, or see here, hogging, sagging. Tell the answer with sign, fast. Plus 70.27. It is plus 70.27. That means it is sagging. Tension is on right side or left side? Tell me. Tension comes on right side or left side? Tension comes on right or left side? Tension comes on right or left side? Right side. Okay. Now BMD. See, at the top tension is left side. How much answer? It is 40.34. Space is not there. 40.34. Here also tension this side of 63.83. At we have point J point, tension is inside of how much? 70.27. So your BMD will be like this. Or see here only. See here only. Hogging, tension this side. Hogging, tension this side. Sagging, tension inside. Fully clear? Fast. Fully clear? Full clear or not? Anyway, remember, in the course, in our regular course, these all I will explain more and more again. And tomorrow's class with pendants, second round is there to understand. Today little time problem. Why? It took lot of time. Tomorrow I can save the time because free body is ready. Okay. Lastly, this is not AB, sorry. What I wrote is for BE earlier. Now for CF. For CF, see here. CF member, load is this side. So I will take, this is sagging. Clear? CF member, see load is this side. I will take, this is sagging. So, bending moment at C. Nodili, CLE. This is sagging. Nodi. It is hogging. Minus 58 point, what is that value there? 58.58. That is hogging. No, that is not sagging, it is hogging. You stand here. This is sagging. This is sagging. If this is sagging, this is hogging. So tension on the right side. BM at F is minus 90.71. That is hogging, tension right. And lastly, BM at one point is there. What is that point? That is called K. At K equal to, look this side, plus 128.03 into this distance is, we already calculated. Where is the distance? The distance is, where is it? here 2.134 into 2.134 minus 90.71 minus 60 into 2.134 into 2.134 by 2. Tell the answer. Tomorrow for column I will explain once again tomorrow, because why? I am taking two hinged support here. So this confusion, tomorrow I will eliminate more. Clear? Any confusion, tomorrow full board is there for me. Why? Because tomorrow this space is not required for me. Okay. What is the answer? Tell me. Answer. Tomorrow we have full board. Therefore, I will first draw SFD and BMD. I will explain once again tomorrow. Answer, answer. With sign answer. With sign answer. Plus 45.89. Plus 45.89. That means it is actually sagging tension on the left side. So here minus, how much it is? 58.58. Here 90.71. And here at what distance? At distance 2.134 meter. It is inside tension of 45.89 joined by a parabola. Okay. This is the BMD on tension side. Fully clear? I will explain more tomorrow, because today time problem. I will explain the columns once again tomorrow. No problem. Tomorrow I will explain the column once again. Don't worry. I will make it further more clear tomorrow. Okay. Now if you draw elastic curve, if at all you require, I want to write here. See now, suppose you draw elastic curve here. I will tell how is the elastic curve. See here. This is the original position. Roughly I will draw. Elastic curve. Tension upper side, fixed end, hog, sag, hog. Hogging will continue. Then sag, hog, hog, sag, sag, hog. Here, see, negative means what? Tension this side. Somewhat hogging, then, so load is this side. Somewhat hogging, see, tension is this side, then tension inside, again tension this side. For that member, it is what? Here. Load is this side, see, tension is that side. Somewhat like this, roughly. Or, I will tell you now, see, tension is upper side, hog. Tension is this side, sag, this way, tension. Here, tension is that side, this way. Here, tension is upper side. Tension is lower side. Tension is upper side. Tension is upper side. Tension is lower side. Tension is upper side. Here, tension is this side. Tension is that side. Tension is this side. Tension is that side. Tension is this side. Tension is that side. Clear? This is roughly to understand. Now, I will do one thing. So many people, unfortunately, does not know BMD on tension side. They start wondering, sir, ಕನ್ನಡದಲ್ಲಿ ನಮಗೆ ಕಾಲೇಜಲ್ಲಿ ಬೇರೆ ಹೇಳ್ಕೊಟ್ಟಿದ್ದಾರೆ ಸರ್, ಹಿಂದಿಲಿ ಸರ್ हमको किसी और तरीके बताया, वो भी बताता हूँ ನೋಡಿ. That also I will show you. ನೋಡಿ, that is called superimposing principle. But remember, superimposing principle is only academic. It will not what? Give correct BMD. Only examination you can do it. Okay, I will draw that one. This is very, very easier. I will not explain much. I will tell you how to draw it. Easy method is there. I will not explain too much because it's a crude method and also only academic. Superimposing principle. Frame is here. AB, BC, CD. First plot end moment diagram. The negative means what? On the loaded side, or crude method, plot on the tail side. See, very crude method. End moment diagram, plot on the tail side. Okay, see, 103.19 here, 63.62 for this member, 62 for that member, over, joined by a straight line. Then 103.96. Here 123.73. Joined by a straight line. No loading to be seen. Here 65.15. Here 93.42. Joined by a straight line. Here tails are on the left side. Left side 40.34. Here 63.83. Joined by a straight line. Here that side 58.58. Here 90.71. Join. Now over this one superimpose the BMD. See, this is point A, this is B, this is C, this is D, this is E, this is F. Superimpose the BMD for simply support beam. There you have to plot on the loaded side. So now easy for UDL, WL square by 8, 30 into 6 square divided by 8, 135 here. That is 135 here. Center. Center is 135. Some will tell, sir, yes sir, this is how you are drawing. It will smoothly. ಸರಿಯಾಗಿ ಬಂದಿಲ್ಲ, ಓಕೆ ಬಿಡಿ, ಪರವಾಗಿಲ್ಲ, ಆಯ್ತು. Now negative, positive, negative. Here WL by 4 central load 204 by 4 is 200. Nodi how fast it is. This full is 200. Negative, positive, negative. Here WAB by L 150 into 2 into 3 divided by 5 180. Here 180 little upper side 180. Negative, positive, negative. Here point load WAB by L 100 into 3 into 2 divided by 5 is 120 here. 120. Loaded side you have to plot. Negative, positive, negative. Here WL square by 8. 60 into 4 square divided by 8 is 120. Negative, positive, negative. Now elastic curve. Negative, hogging. Positive, sagging. Negative, hogging. Negative, hogging. Positive, sagging. Negative, hogging. Negative, hogging. Positive, sagging. Negative, hogging. Here this is sagging. Negative, hogging. Positive, sagging. Negative, hogging. Here this is sagging. Negative, hogging. Positive, sagging. Negative, hogging. This is what academically people do in examination. What we have drawn on BMD on tension side, that is practical oriented. Okay. Now completely clear. I will tell you now. Completely clear. Past, tell me. Completely clear means I will do one thing now. I will start second question, not today. Tomorrow I will start. Okay. Now see, I will tell you question number 2. I will start now so that no time waste. Question number 2 has got this support hinged end. This is hinged support, and also this is hinged support. Hinged support. Therefore, the moments are going to change, and this moment is coming 0, and this is not 0. That is there. A moment is there. Ayo, small mistake rubbed out. Okay. I will give a moment for you so that you can start. This moment is 0, not there. This is 0. The moments are, I noted down there, 111.01. See, 111.01 all in kilometer meter. 111. I write neatly. 111.01 MBA is 47.97 clockwise. It is changing. Anti-clockwise of 106.15. 106.15. Clockwise of 138.14. That is second question. Anti-clockwise of 92.48. MDC equal to 0. This is anti-clockwise of 45.66. This is clockwise of 97.17. 97.17. This is clockwise of 58.17. Remember, this is 0, this is 0. For this question, tomorrow's class, before coming to the class, can you get all the reactions? Tell me. Can you get all the reactions? I will directly enter during my free time. Tomorrow when I start the class, I will put this free body for second question will be ready on the board. Reaction I will calculate before the class. Agreed? So today only for the second question, loading is same. Loading all same. Loading all same. You do one thing. You calculate the reactions. Some moments are 0. Agreed? First. Agreed or not? You should get ready with the free body. Free body I will write before the class. I will do one thing now. Free body I will write here so that I get good space for SFDBMD. Okay, done. Thank you. Tomorrow we will meet. See, tomorrow class will be again in YouTube. Day of tomorrow, what I will do? The 2 questions I will solve by which method? Day of tomorrow. That is not in not in YouTube. We will go back to our original class, Zoom. We will solve the 2 questions by which method? MD method and. We will solve the 2 questions by which one? MD method and. Pending. MD method and. Day of tomorrow class in Zoom once again. We will solve the 2 questions. MD and Kani. Remember, are you sure that by those methods, same answer will come? Are you sure? Tell me. Those who are attending the class regularly, are you 100% sure? Ditto same value will come. End moment will not change. Yes, it is guaranteed. I told. It is impossible that different value will come. So, this is what all I explained is for SD method, MD method and Kani's method or any method you solve. Okay, thank you. We will meet tomorrow. I will close this question in the YouTube. Day of tomorrow, Friday, once again you will go back to Zoom class for continuing MD and Kani's method. Okay. Thank you. Go through and tomorrow you be ready with the reactions. I told you, be ready with the reactions. Don't waste time tomorrow. Be ready with the reactions tomorrow. Okay, thank you.